Hi everyone, this is Renee Garcia, and I'd like to talk to you about the scientific method. What is the method? Essentially, the scientific method is a set of steps that were created to allow scientists from every country, every culture, every language to follow the same protocol and produce the same results. It's based on very important concepts, two very important concepts. The first is hypotheses. This is essentially a provisional and untested explanation of a phenomenon which requires verification. It means that something has not been tested. Theory is a hypothesis that has been tested and has been proven. This is essential. It also helps to organize and predict how new facts may fit into the established pattern. So, one of the main challenges of science and scientific method is the misunderstanding between the use of hypotheses versus theory. A hypothesis, as I said, is untested. However, in much of literature, television, movies, articles, you name it, it's often presented where an individual will say, well, it's just a theory, but I think this. And this is completely incorrect, because if someone is just thinking about something and it hasn't been tested, then that is a hypothesis. And when we use theory in place of hypotheses, we demonstrate an understanding that we simply do not have about an object or an observation or something. The method itself starts with observation and a description of a phenomenon. Now, this could be anything you see, anything you hear, anything you want to find out more about. Okay, so you describe it and then you write it down and you begin research. Now, the research is to give you any background information, if there is any. Sometimes we ask a question and we create a statement, a hypothesis, and it's the first time it's ever been done, and that's great, that's cool. Sometimes it's not, and it's something we want to make sure we have all the information on it. So in this case, we are going to form a hypothesis, and a hypothesis is a statement, it's not a question. And the difference is that a question leaves a more open-ended response, and we don't want that. We want to test whether our statement is true or false. So we are either going to prove it or we're not going to prove it. In this case, my statement is simple. Vaccines cause autism. So we want to identify the variables that are necessary to prove or disprove this statement. And in this case, I'm going to use my observations and my questions to create that statement so that I can make sure that it is exactly what I want it to be. Now, I could go on and say specific vaccines cause autism, or I could say vaccines cause behaviors that are similar to autism. So I could be more specific in various ways, but for this example, I'm just going to make the statement, vaccines cause autism. In this case, there are two types of variables. There are independent variables, and these are the ones that are within the context of the study. So this means that these are things that I can change or I can control in my experiment. So for this example, the dose of the vaccine, the type of vaccine, the type of symptoms of the vaccines, or the type of symptoms of autism. The dependent variables are those that may change due to the independent variables, and that's essentially whether or not vaccines cause autism. So I'm going to test the hypotheses, which means I'm going to experiment with the data to prove it's true. In this case, because it's a statement that says vaccines cause autism, I'm trying to prove that statement to be true. But in doing so, I may prove that it's not true. So at this point, the evidence will tell me if my hypothesis is correct or not. Then, with that evidence, I will draw conclusions. So using the information in the data and my observations, I can try to answer that that particular statement of whether it's true or not true. So now let me give you a little bit of background about science and why the method is so valuable today. So early scientists, and we're talking, let's say, from the the first tests of vaccines in the early 19th century and 20th century to almost the 21st century, one of the greatest jobs you could have would be to be a scientist. And it didn't matter if you worked for NASA or anything else. If you said you were a scientist, wow, that was like being a superhero. Then, about 2001, when George W. Bush was elected, he introduced two terms with the word science that changed the perception of science, not just in America, but in the world. He began to use this term sound versus unsound science, and this was mainly related to issues of global warming and stem cell research. Because he felt morally that stem cell research was wrong, he said that it was based on unsound science, which gives one the impression that the science was untrustworthy. However, America was not the only country working on stem cell research, and while George W. Bush stopped all government funding to stem cell research in America, other countries went on doing it for the next 9 years, or 8 years that Bush was still in the White House. So his use of the term sound versus unsound created a disbelief of science that we'd never seen in America before. And this started to erode the foundation of Americans' trust in the idea of science and in scientists. And it wasn't until Trump where this was accentuated even further, and there was a statement made by Christine Todd Whitman, who was the former head of the EPA under George W. Trump, if you can believe this. She actually said that Trump had a demonstrated, orchestrated war on the environment and science. I'm sorry, it says or science, but on the environment and science. So that this was definitely a way to cause disbelief among Americans even further, and thereby allowing lobbyists of fossil fuel companies and others, including vaccinations, etc., to be destabilized. And it did happen. So I want to explain to you why it's important, why the method is important. So the method allows for the development and testing of hypotheses. It permits various types of bias to be addressed and controlled. And it can be retested with new information. Now let me demonstrate to you how this has worked and why it's important. Okay, so we're back to vaccines and autism. The statement is actually one that really does exist in America and other countries. And it basically started by one man who was a former English doctor, Andrew Wakefield. He produced a paper that stated a connection between vaccinations and autism. So this paper was first published in 1998, and he claimed that there was a link between the measles, mumps, and rubella vaccine, the MMR vaccine, and autism. That children getting this vaccine would or could become autistic. Okay. Now, the issue is that there was a huge amount of publicity about this, and people believed it. Regular people on the street believed it. However, no doctors supported this. No other doctors supported this idea. It basically went word of mouth from mother to mother, but not to pediatrician to mother. They did not endorse this belief at all. And the main reason is because it was never proven. His paper was evaluated by a multitude of other physicians, and I mean immunologists specifically, around the world, and not one iota of evidence was ever discovered that linked MMR to autism or any other vaccine for that matter. In fact, it went to such a degree that he was actually banned as a doctor in England and in America, and lost all credibility as a physician. So why this is important to know is because the scientific method allows us to evaluate these kinds of big questions and to determine whether they are valid or not. Now, the thing is, vaccines and other aspects of research can be evaluated using the scientific method. But fear is not scientific. Fear, as said by the prince in Dune, fear is the mind killer. And this is the problem that we see with people in America that refuse to believe that vaccines do not cause autism, or that there are issues with even the current COVID vaccine. So it's very important to read articles on your own and educate yourself about some of these issues, because the scientific method is just a method. Thank you.